All right, so here we are, Linux. So one of the best ways to learn Linux is to get Linux, is to use Linux, is to get involved, immerse yourself in the operating system. And I remember the first time, I started learning this stuff, it was super difficult to understand. It was kind of frustrating. You see the white text with the black terminal and you feel like you need to be somebody out of like the Matrix or Hackers or something like that. It's really not that complicated. You're going to see why. It's pretty straightforward and intuitive once you start to use it on a regular basis. So first thing we're going to do is we're going to get Kali. So Kali is an offensive penetration testing cybersecurity attack platform. There's other Linux distros out there. Kali is based on Debian, but there are distros, for example, there's Arch Linux, there is Ubuntu, there's Mint Linux. There's so many different distros, but we're just going to go ahead and jump into it. And, we're going to go with this one. We're going to roll with it. It's very popular. And once you learn this particular distro, learning the other distros would be pretty straightforward. All right, so let's just jump right in by clicking download. And the easiest way to install this is to just grab the VMware image. So we're going to grab that. And let's scroll down and find the 64-bit version right here. Bam. We're going to let this download, and when it finishes, we'll circle back and we'll jump in. Okay, so about 5 minutes later, everything's downloaded. All right, now we've got Kali. We need VMware Workstation. And we can download the trial from VMware.com. The site may change in the future, but the idea is you want to go to their products, and then you want to look for the desktop hypervisors, which should display in the left pane in a moment. Let's see. Here we go. Desktop hypervisor. VMware Workstation Pro. Very cool. So just download the latest version. All right, download. Very cool. Let's get the VMware Workstation Pro for Windows. It's saying it could hurt your computer because it's an executable. It's not a virus. Okay, so we can go ahead and keep that and we'll let it download. Once it finishes, we'll come back and we'll start installing these things. Okay, so both are downloaded. As you can see, we have Kali and VMware Workstation. So just install it, right? So you double click VMware Workstation Pro. This is the trial. We will go ahead and proceed with the installation. Currently version 16 is the most recent. By the time you watch this, it might be version 20, right? I mean, VMware is constantly evolving. Software is constantly updating and changing. But the installation process and the functionality should basically be the same. So we'll just click yes through the wizard. Now, since I already have VMware Workstation installed, my wizard looks a little bit different than yours. But basically, the idea is that you're going to want to install the enhanced keyboard driver, and you want to put VMware Workstation console tools into your system path, right? And yours is going to say install. Mine doesn't say that because, again, I already have it installed. But once it finishes, you will see something that looks like this. Let's start up VMware Workstation. Bam, right? So now we can create a new virtual machine, but we don't want to do that. But now what we want to do is extract Kali Linux. So let's go back to Kali and we'll right click and we'll say WinZip or 7-zip extract to here. Now I'm using a tool called 7-zip. You may not have 7-zip, that's cool. You can just Google 7-zip or you could just go to, I think it's 7zip.org. That's where you can just download the executable, install it. And then you'll have the ability to right click and archive and unzip it the way I'm doing it. All right, so we're going to let this run, and when it finishes, we'll circle back and continue our setup. All right, so now we've got this new folder, Kali Linux. Double click in here, double click in there, and you'll see a bunch of files, right? Don't let this freak you out. This is basically a virtual machine disk. This is the configuration file. There's a snapshot file. There's virtual RAM file, right? So we're basically setting up a virtual machine. And this virtual machine is going to behave just like a real machine, except the desktop hypervisor, VMware Workstation, is going to lie to our computer, which is known as the host, and it's going to say, hey, this virtual machine is actually real, right? It's going to basically emulate the hardware and, the keyboard, the mouse, the hard drive, all that stuff is going to be emulated by VMware Workstation. You'll see it's not as complicated as it sounds. So all we need to do is double click the VMX. And it should open in VMware Workstation. Look at that. It's pretty cool, right? And if you look down here in the description, you get some information. And you can see here it gives you the username and password to log in. Kali. So we're just going to power it on. And we're going to say, I copied it. Let's go ahead and minimize this guy. Close home. And then once this boots up, we'll go ahead and jump back in. All right, we're all booted up. I'm going to press Control-Alt to escape the VM. I'm just going to open up the library because I want to rename this. Let's see, rename to Kali 2020.1. Right, I just renamed it the way it's displayed here. I'm going to create a new folder too. New folder. Learn. Got this new folder. Actually, I don't need a new folder. Let's delete this because I'm just going to drag this into Learning Linux. And now we've got it in here. And you can see some of my other courses are in here, the stuff that I've been teaching. Some of my other labs are set up. But we've got this here, and now we can log in with Kali. And here we are. So I'm just going to close this library pane. And in the next lecture, we're actually going to start exploring, ready to dig in, right? The goal of this class is to get you up and running with Linux fast. So we're not going to waste any time. I will see you in the next lecture when we dig into Linux. All right, see you soon. Bye. Okay, so in the last lecture, we quickly installed Kali Linux and VMware Workstation. Now we're going to configure Kali Linux so that in subsequent lessons, we can start to learn Linux. So there's a couple of things first. The screen isn't at the ideal resolution and we can't really drag and drop files, so we're going to fix that really fast. And don't worry, we're going to go into some of the details of what we're doing in future lessons, but right now we just want to get this set up. So we're going to do sudo apt update tech-y. I'm going to type in the password, Kali for Kali. And again, we're going to explain all this in later lessons. Right now, we just need to, just get everything updated and mainly just get our open desktop tools installed in Kali. All right, very cool. Control-Shift-V. And I'm going to press Enter. And let me just show you what I typed. So this is Open VM Tools Desktop. And this is Fuse. You need to install both of these so that you can drag and drop files from your host. Let me press Control-Alt to escape the guest. From the host, this is my host operating system. This is the guest operating system. And by installing Open Desktop Tools, I'm able to drag and drop between both. All right, so we've got that set up. That should be good to go there. Let's just change this resolution real quick. Close the terminal, go here, and I'm going to enable high DPI. By typing DPI, I'm going to click Kali high DPI mode. I'll say yes, I do want to use this. Control-Alt to escape the VM, and then I'm just going to resize this window to 1920 by 1080, just to make it a little bit nicer and easier on the eyes. All right. Last thing I'm going to do is I'm just going to change the background because I don't like this wallpaper. Okay, you don't have to do this. This is just me being a stickler. And then we will change the power option. So I'll click in the upper left corner. I'll type power, click on Power Manager, and then I will make sure that the system does not go to sleep. So we're going to basically go to plugged in. Let's see. I think display, this is what we want. Yeah, display power management, turn it off. And we'll click plugged in, and then we'll change this to never, so that the power never goes off in this VM. And then when the screensaver is activated, we don't actually want to lock the session, right? So let's just never lock the session. Lock screen when system's going to sleep, nope. And everything else looks good here. Close out, good to go. All right, so in the next lecture, we will dig into the terminal. I'll see you in the next lecture. Let's not waste any time here. Let's just solve the elephant in the room. Linux is intimidating. Let's just get that off the bat right now, because it is, right? I remember the first time I started learning this. I started my cybersecurity career in the university, in the help desk, reformatting both student and professor computers. And I remember feeling just trepidation, every time one of the network admins, would SSH into a network appliance, or I heard about some Internet of Things device running Linux. I knew they were all running Linux. I knew that I needed to know Linux, but it was scary. It's that big black screen with arcane text and a blinking cursor that just is taunting me and it's just daring me. And I felt like every time I lost the dare. But I'm going to tell you right now, Linux does not have to be that way. It doesn't have to be that way at all. It's actually easy. It's easy to learn, and you're going to see why in these coming lectures. So we're going to get right into it. I'm going to show you why it's easy. And I think you're going to agree after you get through this course, it is not as bad as you thought. So the first thing we need to do, of course, is we need to get into the terminal. So how do we do that? Well, you see this little black box up here? It says terminal emulator. Use the command line. Once you gain competency in the terminal and you learn some of the tricks I'm going to show you in these first few lectures, you're going to immediately begin to feel more confident with Linux. And then we'll start to get into some of the nitty-gritty details in subsequent lessons. But right now, just click the terminal and then click this little maximize button here. And now you're in the terminal. So the first thing that we need to do, change our password, right? Because right now, our password is Callie. And everybody knows that password. It's not safe. Username Callie, password Callie. Right? So let's change that password. We go to the terminal. And as we begin to type, notice the text is red. It will change to teal when it completes. Now, all terminals don't do this. Callie is one of them that does it. We're actually using ZSH or bash. So we're using ZSH. That's the name of the shell. And we'll talk about all this later. But this particular shell does this kind of highlighting with text for binaries that are actually existed on the system, okay? Let's clear out the page. So if we type past WD, what do you think that does? It changes your password, right? Type this in, and it says changing current password for Callie. This is my current username. This is my host name. Okay, so I'm changing the password for this user. My current password is Callie. And my new password, I can type that in now. Now, one thing about Linux that's different than some other operating systems, especially Windows, is that Windows will echo hidden characters as a star or an asterisk or a dot. Linux doesn't give you any output to standard output. That's what this terminal is known as, standard output. This is known as standard output. Linux doesn't echo by default passwords to the screen, even in an obfuscated version. So it's not very forgiving there. You may not feel like you're doing anything when you type a password in because you're not getting that response. You're not seeing that asterisk or that dot, but it's working. Okay, you're gonna have to get comfortable with that. It's gonna take some time, but soon it will make sense, or it will feel intuitive. So if we type exit the terminal, and now we should be able to log out and log back in with our new password. So if I type Callie and I put the old password, it should fail. Password incorrect. I type the new password, and voila, we're back in. So you just type your first command. That's really cool, right? So one other thing I want to show you before we end this lesson is if we go back into the terminal, there's something called sudo. So there is in Kali Linux a tool called nmap. Okay, we're not going to get into what this does in full detail, but this tool allows you to essentially scan a computer for open ports, and you can discover vulnerabilities and things like that. But nmap's scope of visibility is limited by the permissions of the account that's running it. And so my current account, Callie, has permissions that are less than root. Root is like God mode. It's the administrator account in Windows systems. Think about it like that. It's kind of analogous. And so if you want to temporarily run a command in a higher security context. Think about right-clicking on an executable in Windows and saying, run as administrator. And that little dialog box pops up and it says, please enter the administrator username and password. That's what this command does, called sudo. So sudo in map, what this will do is it will basically switch user and then do this command. What users are switching to? Switching to an account that has permissions to run nmap in a higher privilege context, and that will be root. So when you do this, I put my password in for Callie, and it's going to run it with the permissions of root. Now, for the password, I typed in my password, not root's password, and that's because my account, if I type who am I? My account Callie is a part of a group known as the sudoers group, and anybody in that group has permission to run sudo. Okay, so I hope that kind of makes sense, and if it doesn't, it will later as we go through this course. So right now, I just want to congratulate you for opening the terminal and getting in here, and not letting it daunt you. Right, it's not easy doing this, and I'm going to try to make this as fun, fast, and educational as possible. All right, so in the next lecture, we're going to get into tab completion. So I will see you there. All right, bye. So last lecture we did sort of a gentle introduction into Linux, and now I'm going to show you the beauty of tab complete. So let's say we have something we want to see. Let's say we just want to list all the files in this current directory. So I could type ls to list, and we'll talk about what this command does a little bit later, a little bit of the details of what you can do, but you can just type ls space and then d. And if I hit tab, notice it shows you all of the folders or files that start with a D, right? Now you notice there's two that start with DO, documents and downloads. So what do you think is going to happen if I type DO and then I hit tab? See that? It just shows you now the folders that have the matching first characters of DO. And if you had files here, you could also do the same there. So this one thing, this one little trick, tab complete, will make you feel like a Linux aficionado. Right? Autocomplete is absolutely amazing because you can hit tab at any time and get help. And we're going to do that throughout this course. And you're going to see just how useful it is as we progress. All right, so in the next lecture, we are going to dig into the command line history. We're going to show you what you can do with that. So I'll see you in the next lecture. So the last lecture was a gentle introduction into tab completion, and now I want to show you some command line history tricks. So in the Linux terminal, it's really, really easy to recall the last command or group of commands that you typed. All I have to do is press the up arrow, and every time I press the up arrow, it takes me back to a command that I typed, right? And when I press down, it takes me forward in time to the most recent commands I typed. Very, very cool. Now, if you want to see all the commands, or at least a long list of them, you can type history, press enter, and now you get a list of the commands that I've typed since I've installed Callie. You notice there's a number next to each one. Yes, that means you can actually reference these commands by number. And the way you do that is pretty simple. Let's say I want to run sudo apt update tech-y, but I'm too lazy to type this whole thing out, or too lazy to go press the up arrow a bunch of times. The way to get there is to look at this number, and you would just type bang and the number, enter. Look at that, it puts it on the command line for you, and now you can press enter again. And I need to type the password because it's sudo, but it retypes, it recalls the command for you pretty effortlessly. Now there's one other really, really cool trick that you could do with this, and it's called the reverse case insensitive search. So if I press Control R See, it says back search. It's going to search back through my command history in a case-insensitive fashion. So if I type sudo, you see it brings up sudo apt update tech-y. If I press Control R again, it brings up sudo nmap. Every time I press Control R, it's searching back for every command that matches that string sudo. And then when I have one that I want to use, I just press enter. So that reverse case-insensitive search, Control R, is super sweet. Now, I'm not trying to say this to make you look smart or anything, but I remember using this a couple years back in front of my boss, and yeah, he thought I was a whiz kid. You know, just, I don't know why. I guess a lot of people don't know about this or they don't use it, but if you just master this Control R command and tab completion, you'll be well on your way to Linux mastery. All right, so that's it for this lecture. In the next one, we're going to dig into the Linux file system. I'll see you there. Bye. Okay, so in the last lecture, we talked about searching your history. Now we want to get into the Linux file system, specifically the file system hierarchy, right? So almost every Linux distribution has a way of organizing folders and files, and it's really, really critical that you kind of wrap your mind around the basics here. There's a couple of confusing things, for example, like the root folder and then the /. You know, these are two different things that have the same name, but they're two different things. And there's a couple of other things I want to talk about. So let's just jump right into it. First, we need to look at the file system. So if we run ls / enter, you get a list of the folders in this file system, right? Now, there's a couple of them. And some of the most important ones, we'll dig into those right now. So this bin binary contains essential binaries that are available to the user. So for example, when I run ls, this is a binary. A binary is just Linux lingo for an executable, right? So in Windows, it would be called an executable. In Linux, it's called a binary. And those binaries live in the bin folder, which is short for binary. So ls is a binary that lives here. Cat, which stands for concatenate, that's there, and a few others. That's what that's for. Okay, then we have the boot directory, and boot, this is really all about booting your system, right? You're almost never going to end up in this directory. Let me show you what these folders look like. If we click on this little folder icon here, you can see open folder, go down to file system, and this might make it a little bit easier to see. So again, this boot contains boot information, right? This is the actual kernel. You know, this is the core, the nexus, the central nervous system of Linux lives here. So you will almost never touch these files unless you really, really know what you're doing. Okay, so dev. This used to confuse me because I always thought that this was like a development directory, right? Maybe this is where beta or alpha or functionality, new functionality that was yet to be tested would be released into this dev folder before it was grafted into the final release of Linux. That's actually not what this means. This stands for device. So in Linux, this is a big concept here, okay guys? So in Linux, everything is a file. Everything is a file. That's not the way it is on Windows, okay? So even devices are represented as files. So you see these things, right? Disk, input, keyboards, right? USB drives, the mouse. You see this? These are files. I mean, these are actually files on the file system, which I know is kind of crazy to understand, but that's the way Linux works. Everything's a file. And so all those devices live in this dev folder, okay? So just keep that in mind. That's what this is for. Let's go back up. Etsy. Do not say etc. Nobody says that. This is called Etsy, okay? I don't want you to look silly saying etc. somewhere, but Etsy is all about system configuration files that are available to the entire computer. So you see, for example, Apache in here, right? Or apt, or these different applications. These are all the configuration files. So if I go to Apache 2, I click on this configuration file, you can see this is the configuration, right, for this particular service. So they all live in Etsy. Now, home. Let's talk about this one for a second. So if you go in home, you'll see Kali. This is my home directory. Now, by my, I mean this user, Kali, the user I'm logged in as right now. Okay. And if we go to my home directory, you can see that these folders match these folders because it's the same thing. Think about it kind of like My Documents in Windows language or Windows lingo. It's roughly the same, not exactly the same, but it's pretty close. Now these lib folders, you probably could guess what these are for, but these are libraries, right? So usually .so files, these are shared objects. In Windows, you would call these DLLs or dynamic link libraries. Linux, their version of them, they're just called SOs, and these libraries are shared by many applications, and they all live in these four folders here. So now media, this is all about external media. It's a mount point for removable media like a CD-ROM or CD recorder. I mean, this is kind of old, right? Floppy drives. Nobody uses those anymore, but you'll see here that we have mount points for your CD-ROM. Again, you see it's represented as a folder because everything is a file. So your CD-ROM would live inside that folder as a file. I don't have one connected to this computer, but if I did, you would see it there. And MNT is a temporary mount point. So this is more permanent. This is temporary. So if you have, a directory that you want to mount, maybe you have a hard drive from a different computer, or maybe there's a different partition on this current computer, you can mount it temporarily to this drive and you can inspect it, view it. And depending on your permissions, you can write to it. That's what MNT is for, mount. Opt. I like opt. Opt is optional software packages. So this is kind of like program files in Windows. I'm really trying to make it analogous to something you might already know. These are optional packages. So if you go online, or maybe if you go to GitHub, you can download something, you would typically install it in opt. Maybe, if you download an application, though, if you install it through the package manager, apt, and we'll learn about that a little bit later, it's not going to end up in opt, right? It's going to end up in the binary, the bin folder or the user bin folder, which is right here, user bin. Right, these are all the user binaries. So you see 7-zip is in here. You see all the attack tools are in here, right? Error crack. Remember, this is an offensive penetration testing Linux distribution, so it has a lot of attack tools inside of this distro, and they all live in this user bin folder. But opt is more just for optional applications. Usually go there. Now proc, this is kind of weird. Because everything's a file, that means even the processes are files. So in Windows, when you open a task manager, you see a list of processes, and they have IDs, they have different values, different statistics and metadata associated with them. In Linux, each process is a folder with a name that corresponds to its ID. And if you open up the folder, you're actually inspecting the internals of that process, the address space, the virtual memory allocations, the modules that are loaded. All that stuff is represented as files and folders. I mean, it's weird. I know it's really, really weird, but that's how Linux works. Everything's a file. Everything is a file. There's one thing that you get out of this course. I want you to learn that everything's a file. The next thing that's coming up is also kind of weird. So it actually took me a while to get this. I don't know why it took me so long to understand this, but you see how this says root? Interesting, right? Of course I can't get in there because I'm not root. What is this? What is this directory? So there's a bit of ambiguity here because there are actually two different things that have the same name. If I do this, this is the top level directory and it's called root. It's the root of the folder hierarchy. Okay. If I do this, this is the home directory for the user named root. It's like c:\users/administrator for Windows. That's what this directory is, okay? This is the home directory for my current user, Kali. So this would be like c:\users/Kali, right? But this right here, it just represents the root of the file system, the topmost directory, So I hope that's clear. I hope that makes sense. I know that they have the same name, but they are two different things. Run, you're not really ever going to use that. SBIN, these are for system binaries. So, if config, ping, stuff like that. Think about it kind of like C:\Windows /system32, right? These are all the critical system binaries. Run out of here. And let's go up again. I never use that directory or sys. Temp, this directory is a temporary folder, right? So any files you put in here will not survive a reboot. They are transient. User, this is for the user to put, files. This is just another folder that contains binaries for the user. A bunch of binaries that the user can use. So all inside of here, dig, this is for DNS. Diff, you can run differences between two different files. You can see the differences between them. Depackage, this is an installation manager. A bunch of different things in here. Okay. And finally, var. This is where you're going to find kind of like your logs and things like that, right? So var www, that's for HTML root. Usually that's where HTML files are served out of if you have the web server service running on your Linux box. Var log messages is where you usually have your messages. Where's var log messages? Here we go. So usually you have like logs inside of there. We're not going to go into that now, but that's basically where your logs are stored in this var folder. That's really all you need to know for this. I don't want to go any deeper than this. If you're going to remember anything, just remember that this root folder is root's home directory. The topmost directory on a file system is called root. And just remember that everything's a file and the processes are stored in the proc directory and your devices are in your dev directory. You should be good to go with just that. All right, so in the next lecture, we're going to get into navigating around the file system using the terminal. So I will see you then. All right. All right, so in the last lecture, we talked about the file system hierarchy, and now let's just talk about getting around the file system and also getting around the command line. I'll show you what I mean by that in a moment. So one thing you could do is, when you get into Linux, you want to know, where am I? You want to orient yourself. And I said this earlier, this is your username, this is your host name or your computer name. This is the directory that you're in. And this tilde means you're in your home directory. So if I type print working directory, you'll see it's showing me that I'm in the home directory. Now this tilde is also interesting because it's a way that you can get back to your home directory. Let's say I'm in root, print working directory, I'm in root, right? You can see this is the root directory, I'm not in my home directory. If I want to get back to my home directory, I can just type cd tilde. Now I'm back there. Okay, I can also get there if, clear the screen, clear. So again, we see we're in the root directory. I could just type cd. That also gets me back. Okay, so there's a couple ways to get back to your home directory. And then you notice when I typed cd tac, it took me back to the directory I was in previously. So let me show you what this means. If I go to a directory, and then I go to the root directory. If I type print working directory, you can see I'm in root. If I type cd tac, it takes me back to the previous directory I was in. Okay? And then cd tilde, or just cd, takes me back home. So it's going to take you some practice before this becomes intuitive, but that's basically how this works. Now, the only other thing I want to show you is some command line tricks. So if I clear the screen, press up to go back to one of the previous commands I entered. Let's say you have this long command here, right? You could left arrow to go all the way to the beginning, or you can hold down the control key to move left and right one word at a time. But let's say you had a really long command here. Let me show you one. So again, I can move left and right by holding that control and pressing left and right. But because this is so long, I can actually just press Control A to jump immediately to the beginning, and then Control E to go to the end. So Control A think A is the beginning of the alphabet, so that takes you to the beginning of the line. And then Control E is the end. E begins with the word end, or the word end begins with the letter E, so that takes you to the end. Then, if you want to move it left and right, you can use the left and right arrow keys, or you can hold down Control and press the left and right arrow keys to move by one word at a time. Now, if you want to delete this line, you could just go through everything, right? And backspace it all out. Or another way you can do this, Control C to just exit it. But there's an even more clever way to get rid of it. If you want to get rid of this long line, all you need to do is press Control U. Done. The whole line is cleared out. Okay, so those are the big ones, right? I'm in the home directory. That's what the tilde is. CD tilde takes you home, or CD takes you home. This is how you print the directory you're in. And then to move around the commands, you can hold down Control and move left and right. Control A to the beginning, Control E for the end, and then Control U to clear it out. Make sense? Hope so. Because in the next lecture, we're going to have fun listing files and directories. Okay, so I'll show you how to do that in the next lecture. We've already done it a little bit, but we're going to dig into a little bit more detail in the next lecture, all right? So I'll see you guys there. Bye. Alright, so in the last lecture we talked about navigating around the file system, things like that, and also some command line foo. And now I want to talk about listing files and directories. Right, so we already kind of used this a little bit, this command. So if you type ls, just think about it like list, it will obviously list everything, all the files and folders inside of this directory. Now, another thing that you could do is if I type CD to go back to my home directory, let me clear it, and then I typed ls, user share word lists, tab complete, press enter, it still shows me what I saw earlier. So I don't need to be in the desired directory in order to list the contents. I can include the full path and get the same result. Now, if I press up to go back, Control left, Control left, Control left, then I could do TAC L. And what this does is it'll list more information. So now what I'm getting is a couple different things. One, I'm getting the type of file. So a dash means it's a file. L means it's a symbolic link. And this means that this particular file redirects to this file. Think about it kind of like a shortcut. Okay. And then if this said D, that would mean it was a normal folder. For example, if we do this, you'll see a bunch of Ds, right? So these are normal folders right here. So let's go back up. What else do we have? Well, we have the user that owns this particular resource, the group that user, or the group that owns this resource. And then we have the size in bytes, we have the timestamp, and then we have, of course, the file. In this case, it's a symbolic link. Here we have an actual file. It looks like it's a .gz file, right? Now this doesn't show everything. So in Linux lingo, if a file starts with a dot, it's hidden. That's how you hide files in Linux. So anytime you type ls, you're not going to see the hidden files by default. You have to type ls tac -la if you want to see everything. Now you can see we have a couple files in here, right? So we've got this, actually this is a directory. So we can see we've got this -g and u pg directory. And if we scroll up, we have a few different things, right? So we've got this file bash history. We know it's a file because it starts with a dash. And then we've got this other file. Now we're going to dig into what this means the next lecture. This is actually the permissions for this particular resource. So we're not going to get into that here. Really, I just want to show you how you can list out your files and folders, and also, see the hidden ones as well. Let's take it just a step further. Let's say you also wanted to sort of get these file sizes in a human readable format, because this is showing bytes, but sometimes it's kind of hard to read this number because there's no commas separating them. So what we can do is we can add the H. And you see what the H did? It actually it changed it into a human readable format. So now we see 4 kilobytes, right? 12K. Whereas before, it showed it like this. It's a big number, right? So it's a little bit easier, in my opinion, if you add the H at the end. It just makes it a little bit easier to read. Now, there's one other thing that you can do that I want to show you that's really important. And you can actually sort the contents of the list in different ways. So I'm not going to show you everything you can do with ls. I'm just showing you the stuff that you're going to actually use every day, right? And no point in showing you things that you're never going to use. So if you want to sort by time, you can put in a T. And now you can actually see the time, right? The most recent is at the top and the older ones are at the bottom. Of course, you can change that easily by just hitting it. The R, put the R at the end, and that will reverse the format. So now the most recent is at the bottom and the oldest is at the top. Pretty cool, right? You can also, if you want to, sort by the size. So if I change this T for time to a S for size, now what you'll see is your biggest files are at top, 12K, right, for this .z shrc file. And then, of course, your shortest files are at the bottom, your smallest files. And so that's really useful. Of course, you can always reverse that, or you can unreverse it by taking off that R. So that is really cool. And one other thing that's really interesting is tree. There's this tool called tree. Sudo, let me show you what this does. And don't worry about this command that I just typed. We're going to get into all this a little bit later. But this package called tree, written by this author, Florian Ernst, what it actually does is it will display an indented directory tree in color. So if I try to type tree, you'll see it shows up. If I didn't have it, I could have installed it like so. But I've already installed it. We'll talk about installing packages later. Control U to clear it out. But if I just type tree now, you'll see it displays it in nice format, right? You've got the folders up here, you've got the nested files inside. It just makes it, a lot prettier and easier to read. So that's really all I want to talk about in this lecture. Just in summary, you can use ls with the -L to list everything, right? So you get the file types, the permissions, the owners, the group that it belongs to, the date and time, the file name. And when you add this A, it also shows you hidden files. H puts it in a human readable format. And then you can choose if you want to sort it by the time. And if you put the R, it puts it in reverse chronological order, or the file size. This again, we'll put it in reverse chronological order. That's it. So I'll see you in the next lecture when we dig into permissions. Okay, so in the last lecture, we talked about listing files and directories, and now I want to get into permissions because this isn't as intuitive as it looks. Permissions, right? Let's go ahead and get into this here. Okay. We've got a couple different things when it comes to permissions. Okay. The first is that you have different permission groups. So you can either have an owner, or you can have a group. And the last one is just everyone else, also known as other. Okay, all users. So as you would imagine, if you have permissions, if the permissions apply to the owner, that's just the owner of that file or directory. If it's the group, then this applies only to the accounts that are actually in that group, and then everyone else is just all the other accounts, right, that don't fit these first two criteria. So inside of each of these permission, I guess you could call them categories, you also have these 3 permission types. So let me go ahead and clear this out. So the first permission type is read. And this is usually represented by an R. And then the second permission type is write. Right, so we've got a W for that. And then finally we have execute. execute. And this is represented by an X, like so. Okay, now it's pretty intuitive when it comes to files, right? I mean, there's nothing really too difficult to understand here. If you have read writes to a file, it means that you can read that file, you can view it, you can view the contents of the file, right? So that's pretty cool. When it comes to write permissions, well, write permissions means that you can modify the file, and execute means that you can execute the file. You can actually run the file. You have permissions to run that file. Where things get a little hairy is when you start talking about directories. Okay, directories. So let me ask you, what do you think read writes mean on a directory? Let's say you have read writes to a directory. How do you read a directory? Think about that. Read writes on the directory. Well, it means if you have a directory, right, it means that you can actually list the files within that directory, right? That's what you can do if you have read writes to a directory. Now, what about write writes? How do you modify the directory? What does that mean? Well, write writes for a directory, what this actually means is that you can create, so you can create new files inside that directory, right? Or you can take an existing file and you can rename it to something else. So you can rename files. Or you also have the ability to just start removing files from that directory. So that's what write writes mean on a directory. You can either create, rename, or remove files. All right, so far I hope this is starting to click a little bit. The last permission that's really important and critical is execute. How do you execute a directory? It's always confused me. Right? Executing files, fine, that makes sense, but how do you execute a directory? Well, if you have execute rights on a directory, it means that you can actually CD, into that directory. And you can CD into that directory, enter the directory, and you can access the files in that directory. Okay? So that's really a difference. Make sure you really understand this. This gives a lot of people problems, and this is part of the thing that makes Linux so confusing. So I want to show you what this looks like in reality. So I'm going to clear the screen. So what we can do, so we can see where we are. We're in the home directory. We have all these files, right? Now, this is a directory, okay? It's owned by me. Who am I? I'm Callie. It's owned by me. And I have read, write, execute permissions on that directory, right? So I can list the files in the directory. I can read it. I can create, rename, or remove files within that directory. That's right. And I can execute, meaning I can CD into that directory, right? Then we have for the group, which also is Callie. Anybody in the Callie group can read and execute, but they can't write to that directory, right? So they can't actually create anything in there. They can't rename any files in there. They can't remove anything else, but they can execute. They can get into the directory and they can list the files of the directory. And the same applies for everyone else. So that's what this lingo is. These are the permissions. And you'll see this all the time. D is for directory. This TAC is for a file. And if it starts with an L, it means a symbolic link, which is just a shortcut like this. It's just a shortcut to another file. So I hope that makes sense. If it doesn't, go ahead and go back over this video, really think about what I'm saying, and take it a couple of times. It's okay if it doesn't click immediately, because it took me a long time before I actually understood this. So it's perfectly fine to feel a little bit uncomfortable with this. And again, you can leave a comment in the comments below, and I'll jump in there and try to help you. Okay. So in the next lecture, we are going to dig into a 4-part series for messing with files. Okay, we're going to talk about creating files, deleting them, renaming them, viewing them, editing them, and archiving them, and a bunch of other things. So it's going to be really, really fun, and I'll see you in the next 4 lectures. All right, see you soon. Bye. So in the last lecture, we explored the convoluted labyrinthian world of permissions. And I say labyrinthian because it's kind of like a labyrinth. It's kind of like a maze. It's not, it doesn't sit very well. But in this lecture, we want to dig into file manipulation, right? So this is going to be a 4-part series. We're going to get into files and manipulating them. And you can see right off the bat, we're in the web root var www.html. And we can use the command we learned, which is ls, to see what's here. And we have 2 files, right? So how do we view this file? Well, of course, we could just open up the file manager here, and we could try to get to it that way. But from the command line, it's a lot, I think, in my opinion, it's a lot faster just to run cat. So if I type cat index tab h tab enter, it now displays the contents of this file. So cat is the way that you can view files, or it's one of the ways. If you just want to view the beginning of the file, you can type head, and this will show just the first 10 lines by default. And of course, tail will show you the last 10 lines by default. Okay, pretty cool. So far, so good, hopefully. All right, now what we can do, of course, we can rename the file if we have permission to. So this is owned by root. So you can see everyone else only has read permission, which is why we were able to read it. But if I try to edit this file, it shouldn't work. We'll talk about editing files later, but let me show you first how to create a file. So if I type touch, and I can say test.html, you can see I can't write to this directory. That's because if we look at the permissions on this directory, let's go up one. You can see HTML is owned by root, and it's in the root group. Everyone else only has read rights to the directory and execute, but we don't have write rights to the directory. Now we might be able to change that temporarily by using sudo, right? So let's go back into the directory. We can type sudo touch test.html. So now you can see by using sudo, we were able to write a file of 0 bytes. Remember, sudo just temporarily elevates our privileges to a higher security context. So even though we wrote the file, it's still owned by root because sudo allows us to run the command as root, right? So if we wanted to delete that file, we can do the opposite of touch. So touch just creates an empty file. To delete the file, we can use rm. And again, I have to do sudo because it's owned by root and I'm not root. But because the Kali user is in the sudoers group, I have the permission to run sudo and temporarily assume the security context of root in order to perform elevated tasks. So we go ahead and run it, get back, and you can see it is now deleted. Pretty cool. If we wanted to rename that file, put it back there, we can run the move command. So sudo move test. We move it to, I don't know, test2.html. Now you can see, by the way, how it has this ghost outline of what it wants me to press. Because I'm using ZSH, I can just press the right arrow key and automatically complete this command that I previously typed. And you can see now it's been renamed as we expected, right? So that is pretty cool. Now, another way, besides using cat to view a file, is to use less. So I can use cat index.html to view the file, or I can use less. Now, why would you use one or the other? Well, the advantage of using less is it allows you to press the up and down arrow keys to actually go through the file. And if you want to search for something specifically, like maybe you want to, I don't know, you have a particular keyword that you want to look for. Maybe you want to look at all the HTML p tags. You can type / and then the thing you want to search for. And you can see now it is now searching for all of the p tags. And every time I press N, it searches another hit, another match. And if I press Shift N, it searches backwards. So lowercase n searches forward, Shift N searches backwards. And then Q quits. And I'm back where I was before. So I hope that makes sense. And it wasn't too difficult what we did today. So we just ran cat and less to view the contents of files. And then I showed you, based on the permissions, why we need to use sudo to look at the files. And I also showed you how to create files and delete them. Okay, so in the next lecture, we're going to get into editing files. And then we're going to get into archiving them and a bunch of other cool things. So I will see you in the next lecture. right, so in the last lecture, we dug into, messing with files, creating, deleting, renaming, viewing files. And now I want to get into actually editing the files. How do you do that? What's the best way to do it? So let's clear the screen by pressing clear, typing clear. And let's go back to see what we're working with. So what we're going to do, you have different ways of editing files. I mean, you could just, again, open a folder. You could just go in there and type in var .html and open the file this way. Type in that. But sometimes you don't have a GUI in Linux, right? Sometimes all you have is a black screen and a blinking cursor. In that case, you need to use some tools. So there's different text editors, right? There's Nano, there's a bunch of different ones. We're going to use Vim. This is the one that you really need to become proficient in because it's ubiquitous. And if you master it, it will make you feel like a Linux guru. It just gives you a really great feeling when you really know how to navigate Vim. So let me show you what I mean by this. So right now we're in the web root. First, let's check to see if the web server service is running. It's not. Okay, we're going to start it real quick. So we'll talk about starting services later and how all this works. Right now, I just need to get this running so I can show you something. So right now we have the web server service listening on port 80. Let's double check that. Now it is. Let's go to web, the web browser. I'm going to search on localhost. All right, so that is pretty cool. Now let me show you how we can edit this file. So what we can do, we can run Vim. So the nice thing about Vim is that it color codes the lines. You can also see the lines, the numbers. If you type in Shift : and then you can see where it says set number. I just type that in and that shows me the line numbers. Now if I press Shift G, it takes me to the bottom. And if I press lowercase g twice, it takes me to the top. Shift G, I jump to the bottom of the page immediately, and then lowercase g twice, jump to the top. DD will delete a line. So now I just delete that line. And I can go back down through here and I can look to see if there's anything else that I want to delete. Maybe I want to delete line 25, DD, DD, DD. Right, so this is how you can just clean things up. If you want to search for something, of course, you can just do the /div, and then in will show you every match. Of course, Shift in will search backwards. So right now we are in the sort of the command mode. If we type I, we can actually edit the text here. Okay, this puts us in insert mode. So what do we want to do? What do we want to add here? Well, let's just change this from configuration overview to something else. If I press Alt Tab, you can see where it says configuration overview, right? Alt Tab, flip over. Let's edit this a little bit. And then when you want to commit your changes, you just hit Escape, Shift ZZ. Then you can refresh the page and update it. So I hope you can see how cool that is. There's a lot more things you can do in Vim, and we're just kind of touching the surface. Set number. You want to copy and paste something, you can hit YY to yank the line. So I just typed YY twice, and then if I hit Shift P, it'll put it in, right? So again I can hit YY and then again Shift P. Every time I do Shift P, it's just going to paste whatever I did. This is not going to work. Edit paste. You can't actually use the menu up here. You have to use the Vim commands. And that's part of the reason why people don't like Vim, or newbies. They find it a little bit daunting. But once you get used to these commands, it'll start to make sense, right? You'll start to get comfortable with it. You'll start to get conversant with it. So again, to save it, I can hit Shift ZZ, or I can do :WQ bang. So either one works. Shift ZZ or :WQ bang will save the results. And that's really it for editing files. Another tool called Nano, right? And you can look at the files that way too. And this actually tells you how you can use it, right? So I can add like another, I can add something here, page down, let's go down. So it works. I can say it really works. Then I can press Control O. Yes, I want to save it as index.html. Then I can press Control X to exit. But there's also other commands, right? Control backslash to replace. You can cut and paste using these other commands here. So it's really useful, but in my opinion, in my experience, if you become proficient with Vim, you'll go a lot further than just being proficient with Nano. So we're going to press Control X to exit. And there you go. So in the next lecture, we're going to dig into archiving files. I'm going to show you how you can compress files and archive them. And then we're going to get into searching and extracting data from files. So we're going to use rep, we're going to use sed, cut, all. And this is where things get really fun. Let's jump into the archive next, and we're going to get into searching and extracting data from your files. I will see you in the next lecture. Okay, so in the last lecture we talked about editing files with Vim and Nano, and now I want to talk about archiving files. So, you could use the extraction utilities that are built into the GUI, but often as a sysadmin, a network admin, a penetration tester, an ethical hacker, a red teamer, you're going to want to know how to use the command line to archive your files. There are really just two primary ways to do this. So you could use tar, or you could use gzip and bzip. So let me draw this out for you so you can see what I'm talking about here. So you have tar, and then you also have gzip and bzip2. So what are the differences between these guys? Well, the thing is that tar just archives. It just takes a bunch of files and it just puts them together in one giant file. So if this file is 1 KB and the other file is 1 KB, let's say they're all 1 KB, then the final file produced by tar should be 4 KB, 4 kilobytes. That's it. It doesn't do any compression, anything like that. Now, gzip and bzip2 do compression. I said do. All right, let's get mature here. So these two do compression. And even though bzip is actually more efficient when it comes to compression, gzip seems to be the most popular compression mechanism. Now, I don't know why that's the case. Most efficient, but it is. And this is efficient. So think of this tar just as gluing a bunch of files together. It's just like, think of tar, it's like sticky stuff, right? The stuff you use when you're, when you're making a road. You're just sticking all the files together into one giant file. Gzip crushes those files down to size, and then bzip2 really crushes them, squeezes them down to a really small size. So let me show you some really cool stuff that we can do. All right, so let's get something to archive. So I'm just going to download a pretty big file because I want to show you the beauty of archiving and how the compression works. So this is a word list, a collection of word lists that penetration testers, ethical hackers, red teamers, security enthusiasts will use when they're conducting a security assessment against a target. Now, of course, this isn't a penetration testing course. This isn't an ethical hacking course. It's a Linux basics course. But I like to cover Linux from the perspective of an ethical hacker because that's my expertise, and that's what most of the courses on the site will be centered around. So we're going to let this continue to march forward, and once it finishes, I'll get back to you. All right, so we're done. Let's hit clear to clear it out. Now we can go to user share word lists, and we should see, I think it's actually here. So we're going to talk about grep a little bit later. I just wanted to make sure I had this folder called sec lists, and I do. So I'm just going to go into that folder, tab complete, enter. And now you can see we've got all these folders in here. So let's get started. So let's go into discovery, and let's go into web content. So we've got some files in here. Let's see, what do we want to grab? All right, so by using the tac-tac-du, I can get the file size, or I can get the file sizes of all the files inside of each folder. So this one looks like it's a pretty good size. Joomla, right? It's in the URLs folder. So let's go into that folder. And let's get a line count. So I know we didn't cover this command. This command right here, this just does a character count, but if you do the TAC-L, it'll give you the number of lines. So see that this file has almost 5,000 lines. This looks like it would be something good to compress. So first I'm going to make sure that we have the tar utility. If I type which tar, like this, it shows me the path. So we didn't talk about that yet either. Don't worry, we're going to get into it a little bit later. But you can see I do have this utility called tar. So again, all this does is it just takes a bunch of files, sticks them together, and creates one giant file, right? So if I did tar and I typed in, let's just do all the files in this directory. I can say create, that's what the C does. And then I can do F for file, and I can name it urls.tar. I'll just put in all the txt files inside this folder. Now, of course, it's saying I can't do it because I don't have permission, probably because it's owned by root. So that's fine. Let's go back in there. cd urls. And let's just do sudo tar minus cf. We'll name it urls.tar. And we'll take all the txt files. Now you can see this file is 330K. It just got bigger because it combined everything. Now, there is something I can do if I wanted to compress it at the same time. So if I have two options, right? Remember, I have that gzip or I have the bzip. So if I wanted to do the gzip feature, if I want to gzip everything together to actually compress it, all I need to do is between the C and the F, I can first print out everything I'm doing with the V flag. This is verbose. And then Z to do gzip. This F has to be last because the next parameter it's expecting is the file, the output file name of everything here that was compressed, all the .txt files. Okay, so this is saying create, and while you create this new tar archive, be verbose, make sure it's gzip compressed, and save it in this output file. And now you can see it's a lot smaller, right? 36K, so it definitely compressed it. Now let's get it even smaller than that. I want to show you what bzip does. All we need to do is change this Z to a J. And we can keep the same extension, but I'm going to change it to the standard bzip extension, which is BZ2. Press enter. And now when we look, you can see it got an even smaller, 31K from 36K. So that is pretty cool. And this is a great way that you can compress files. You know, I don't know why bzip2 isn't used. Like I said earlier, usually you see people using tar, they call them tar balls when you tar up your files like this. But, you know, in my opinion, you know, I think that people should be using bzip2 because it just has a higher compression ratio. Maybe it takes a little bit longer on larger files. That could be part of the reason why it's not more popular. I'm not sure, but that's how you do it. Of course, if you want to unzip it, you just do the opposite, right? So you can just say, instead of saying create, you could say extract. And then it puts everything back in place. It just overwrote what we had there. So if I did sudo remove star.txt, you see that the txt files are gone. And then if I run this command, I'm saying tar, extract the contents, be verbose, print out everything, use bzip2 extraction, and this is the file that we want to extract, this urls.bz2. And now you can see everything came right back. Now there is one other way to do this that's somewhat popular, is zip. So you could just use zip to do this, right? So I could remove everything again. And I could say sudo zip file.zip star.txt. Now if I do this, it's not going to recurse. So if I had subfolders, it would only zip up the topmost directories. And so you need to actually specify TAC-R so that the zip utility knows to recurse. This is one of the reasons why I prefer using tar, the tar utility, but of course tar isn't as ubiquitous as zip. So right now, I don't have any files here. Let's go ahead and untar what we did. So we'll extract the bzip2 archive. We've got files there. And then we will zip everything up. That's a text file. Now you can see we've got this file right here and it compressed it. Of course, to unzip it, you would just type unzip and get it that way. Some people like to use 7-zip. This is another tool. 7-zip, you do -X to extract. Pretty much, you know, usually you're just going to use tar or zip. And I like to use it with the bzip compression. Okay, so I hope that made sense. So just to recap, you've got tar and you've got this bzip2. We're going to focus just on these. Tar just puts everything together. It sticks all the files together. And then bzip2 will actually compress it. And then you can also use the zip to compress as long as you use the -r so that you can recurse down all the little directories, right? So I hope that makes sense. In the next lecture, we are going to dig into extracting, well, actually searching files and then extracting content from them. This is when we're going to use grep. We're going to use a bunch of other tools. We already kind of used a little bit of these earlier in the lecture, but we're going to get a lot deeper in this next lecture. So I will see you guys in a moment. Bye. All right, so in the last lecture, we talked about tarring, compressing, zipping, all that good stuff. Now we're going to get into searching for files, actually searching for strings, particular strings in specific files, right? So this is actually one of my all-time favorite subjects. The reason I love it is because if you master the concepts taught in this lesson, you will become an extremely valuable asset to any organization that hires you. So let's just start with grep. And grep is all about pattern matching. All right, so first we just need to get something we're going to grep through. And I'm going to use Nashang, which I currently don't have. So I'm just going to install it. And again, we're going to talk about installing packages a little bit later. All right, so now let's go locate Nashang. All right, let's update the DB. We'll talk about locate as well a little bit later too, and we'll talk about what I'm doing in future lessons. So don't worry if it feels like I'm going too fast. I am going too fast. That's because I'm not covering that in this lesson. All right, so now we're going to go to this path here. Control-Shift-C, Control-Shift-V, Control-A to go to the beginning, CD, Enter, ls-lahr. All right, so now we have a collection of folders. Nashang is basically a PowerShell post-exploitation framework. So again, this course has a cybersecurity slant, and Nashang is a tool that adversaries as well as red teamers and penetration testers will use in order to move around an environment after they've compromised an asset. So what we're going to do here is I'm just going to show you some bash foo. I'm going to show you some grep foo for searching through some of the files here. So let's say you wanted to look for a reverse shell, right? A reverse shell is just a way to invoke a victim host into communicating with you, the attacker, right? So you get the host to initiate the communication rather than the attacker initiating the communication, because the latter is most likely blocked, but the former isn't. So what we can do is just search for Nashang. Let's say we just want to search for this reverse shell. We can just say something like, all right, grep, and we want to search for the string reverse, and we just want to look for it everywhere, right? So we're saying we want to look for this string reverse in all of these folders, search through all these folders, and return every file, every match that includes this string. Now, of course, it's going to complain because it says these are all directories, right? They are directories. How do we know? Because we see the Ds in front of them, right? So we know that these are directories. So how are we going to get over this? Well, all we need to do is specify a modifier. So we can say tac, and then we put in the tac R, capital R, to tell it to recurse. And now it's showing reverse. But if you notice, it's matching it exactly. It's searching for just the lowercase. And we might not care about the case, right? So we can make it case insensitive. I press the up arrow, and I just tack on an I to make the search case insensitive. And now you can see we've got the uppercase and the lowercase matches. And still we have, which is really nice, the file that it was discovered in. And it includes the full path. So in shells, there's a file called invoke PowerShell udp.ps1, right? So that is kind of cool. But let's say you also wanted to actually get the exact line number that it matched on. Press up. We can just put in the in to include the line numbers. And now we have the exact line numbers where these matches took place, which is kind of cool. But let's say you don't want to know the details. You don't want to see the content of the files. You just want the files that return the match. What you can do, press the up arrow, take this out. We don't need the line numbers. And we're going to add the lowercase l. And that's going to show you all the files that contain the string reverse somewhere in the file, somewhere. We don't know where it is, but it's in these files. But we now know that these files most likely contain reverse shells. So that's a nice kind of a bird's eye view of what's going on in the files, right? It's really cool that you can use this to just kind of get a bird's eye view of what's going on here. Now, there's some other things that we can do that's really interesting. Let's take this one right here. If we copy this, also to copy, I can press Control-Shift-C, okay, and then Control-Shift-V to paste. I can say less to view it, and it doesn't look the way I thought it would look. Let's see. Oh, that's because this is a one-liner. Let's just do the invoke PowerShell TCP, this one. Control-Shift-C, less Control-Shift-V. Here we go. Now, if you notice, this file has a certain structure to it, and some of these lines start with a dot and then a phrase in capital letters, a description, parameters, and an example. This shows you how you can use the command. So wouldn't it be nice if we could just grep out all the examples so that we can pretty much figure out how to use these scripts? Yes, we can do that, and it's really, really quite easy. So what we can do is look at the format of this. So it's dot and then example. And then there's a line underneath that shows the example. Dot example. A line underneath that shows the example. Let's search for this. So what we'll do is we can modify this a little bit. Let's backspace this out. And the line started with a dot and an example. So to say you want to search for a particular keyword that begins a line, you use the caret or the hat symbol. Some people call it a hat. Technically, it's a caret. And then you could say dot example. And what I'm going to do is make it case insensitive. And I want to see the line number, right? And I just want to search everything. Now, of course, it's not going to search down the directories. So I need to put the capital R. And now you can see it. I've got the matches, but I don't actually have the examples. Now, this is where grep is really cool. If you want to see a line before or after a match, you can just use the really, really cool modifier, tac A and tac B. Tac A, one line after the match. Tac B1 shows you one line before the match. But you could do any amount before or after. Right? It doesn't really matter. Let me show you this. We know the matching example came immediately after the match. So we can say tac A1. Bam. There you go. This is so good. So if you want to convert, base 64 to a string, you can use this PowerShell script, and you can just type this command, and then the file that you want to base 64 convert to a string. Right? I mean, this is really, really cool. Right? You get all the examples here, and I can scroll up. You can see all of them. And the cool thing is I can search from any level. Right? So right now I'm in this Nasheng directory. So it is searching through all of these folders because I have the recurse option on, right? Basically what it's doing, Control U, searching through this entire thing, right? All these files because of the recurse. So it's a great find in files feature. I can do after two to see two matches afterwards, or I can just do before one and after one. There was nothing useful before this particular example, but you can see how this could be useful, right? And we're actually going to see how this could be useful in a moment. So let me show you something really cool. Let's take a look at Hashcat. So Hashcat is a password cracking utility. Penetration testers will typically use this, obviously with the explicit permission from an authorized individual in the target organization to crack passwords. This is what attackers are doing, and the penetration testers will come in and do it first so that they could offer value to the target organization and give them a chance to shore up their defenses before the attackers compromise the organization. So if we go up, you can see we've got a bunch of different sort of modes, right? This is a mode, and then we have the name, hash modes, right? But there is an example flag. Let's say I don't know it. I don't know where it is, right? This is a great time for grep. Grep, case insensitive, example. Now I know that I can type this. to get example hashes. Wasn't that cool? See how I just pipe the results of help to grep using this pipe character, and the pipe is just over the backspace, or actually under the backspace, over the enter key. Just hit shift backslash and it should display for you. So now what we can do is we can say example hashes. Let's say we want to find a specific hash. SHA-256 hashes. We could say grep lowercase for SHA-256. But even though we have all the matches, it's not showing us the mode. Right? If you recall earlier, these are showing modes for each of the hashes. So we need to get before 1. So what we can do is go back here. Before 1. There we go. Now we have the mode that we could use to feed to hashcat. Search for mode. And you can basically see, well, you can't really see here from this, but if you read through the help file, you'd see that if you type the mode, that's how you start the cracking, right? You have to specify the mode. Now we have the mode by using grep to find it. So that is pretty cool. Now, one other thing you can do is I want to show you how you can search for strings that don't match. So if we go to the Apache configuration, you'll see that there's a lot in here, right? The lines that begin with a pound symbol are comments. This is really the configuration. Everything else is commented out. It's just metadata or meta text about what you're reading. So let's say you just want to see what is actually enabled. You don't care about the comments, right? And you don't even care about the empty lines. You just want to see what's configured in this configuration file. What can you do? Well, this shows you everything, right? So we can pipe it to grep, case insensitive, and we can say, show me line numbers if you want. But this V says not. And what don't we want to match? Well, we don't want to match lines that start with this pound symbol. So I can say hat, pound, single tick. And now it's going to say, only show me lines that don't begin with a pound. Now this is great, but we still have this white space. So how do we get that out? Well, we could put in a conditional or. So we could say something like this. First, we can do a pipe like this, and then we can say or lines that start and end with nothing, right? So this means start. We already learned that from this right here, right? Lines that start. And the dollar sign means end. So if you have a line that starts and then immediately it ends, there's nothing in between. So that's an empty line. And the only other thing we need to do is escape this pipe. And there you go. Now you have all of the matching configuration parameters without any white space and no comments. So I think that is pretty cool. All right, so that's it for this lecture. In the next one, we will dig into awk. All right, awk is pretty cool. It's another way to slice and dice your data. So I will see you then. Bye. All right, so the last lecture we got into grep. Now we're going to explore awk. So awk is another scripting language that you can use for manipulating data. And the nice thing about awk is that you don't need to compile anything, and you really only need to understand a subset of all the features awk has to offer. So instead of talking about it and what it can do, let's just use it. And we're going to get started by using some example data from securitypluspro.com. All right, so this is how we can get started. So first we need to make sure that we have wget. What is wget? Well, we can say what is wget, and it says it is a non-interactive network downloader. Okay, so we're going to get more into what these commands do a little bit later, but I like giving you a foretaste of what's to come, right? So you kind of have something to look forward to as we go through this course. So let's use wget. I'm using sudo so I can write to this directory as root. Okay, so we're going to say sudo wget https securitypluspro.com, and the output file, we'll call it index.php. And this is really analogous to just viewing the source, right? So if I quit this, and I open up my web browser, and I pop in securitypluspro.com, you'll see when I view source, Control U, that's what we basically pull down, all this raw source code. So Control W to close, clear, and now we have this file. All right, great. So the nice thing about awk is that it splits records delimited by whitespace by default, and it stores them in variable names like $1 or $2, and these dollars represent the different fields that are separated or defined by whitespace. So if we wanted to, for example, extract all the links out of the source code, maybe we just want to see the links. Maybe we want to see where all the links are in this particular web document. We can do that quite easily with awk, right? So we can say awk. If we just do this, print, and then we put in the file name, it's just going to print the entire thing out. So this is the same, Control U, as this. No difference at all, except this one is a lot longer, right? So why would you do this? Well, you don't use awk just for printing out stuff. You use it for slicing and dicing the data. So if we want to just get the links, we can specify this double quote as a delimiter, right? So I can say tac capital F to specify the field delimiter. And then in single quotes, I will put the double quote. This is what we are going to break fields on. So this would be the first field. This would be second field. This will be the third field. So let's see if we can get the second field. Now, of course, we might miss some links because not all of them are stored this way, right? There may be some others that maybe the links come in the first field. This is the first field. This is the second field. So let's just try to do it, right? So Q to go down to the bottom. Let's go ahead and say we want to print the second field. Look at that. Just like that, we extracted some things that aren't links because not everything in the second field is a link. We do have a lot of links. How can we clean it up so we only have links? I hope you're thinking like me. We can pipe this to grep. We can say, search for everything that has HTTP. So we're saying, only return the second field delimited by a double quote, but also make sure it has the HTTP character, or I guess the HTTP string inside of the line. Only return those matches. And now we have a nice list of URLs. And this would make it really easy to inspect. And of course, if we wanted to write it out to a file, we could do that too. All right, we could redirect to links.txt. And now we can say something like this. What happened here? All right, I tried to use mousepad to open it. Let's just grab it. It's in our, what directory is this in? Home directory. So we can go to our folder and let's open the folder, links.txt, bam. Just like that, we've got the links extracted. So that is pretty cool. All right, so that's all I want to show you here. And that's really the main way you're going to use awk. There's, like I said, there's a bunch of other things you can do with it, but using these field separators and changing it from the default whitespace character to whatever you want will help you really get what you need out of your files and make you more valuable to your organization. So the next lecture, we're going to talk about the stream editor. And I really think you're going to like what we have to offer here. I really think you're going to like what you can do with this tool. All right, so let's jump in the next lecture. So in the last lecture, we dug into using awk, and now we just want to finish things out with the stream editor. So sed, there's a ton of stuff you can do with sed as well, where grep excels in matching sed excels in substitution and replacing text in a file. And you can do this even without opening a file. So if we go back to our index.php file, you can see we've got a lot of links that are HTTPS. Let's say for some reason we wanted them to be HTTP. We just want to replace them. I mean, you probably wouldn't want to do that, but this is just to give you an example of what you can do with sed. I could use this following format: sed, and then double ticks, and then the file. And in between these two single apostrophes, you could just type what you want to replace. So you type S for substitute, this with that, right? So let's go ahead and fill this in. We would replace this with HTTPS, change that to HTTP, press enter. And that's because we forgot the final slash here. Now we can go back up and see what we did. If I type less index.php, I search for HTTP, you'll see I still have a bunch of these HTTPS files in here. Every time I press in, you see it didn't really update the file. So what did it do? Well, let's go back and I'll show you. What this does is it does indeed replace every occurrence of HTTPS with HTTP, but it only replaces the first occurrence of the pattern. Okay, that's it. And two, it doesn't actually update the file. It only makes the change in standard out, meaning what you see in the terminal, right? Most of the time, this is not what you want to do. So we can set it to global so that it doesn't stop after the first match. It just keeps going and it replaces every occurrence of the match. And then we can also use the slash, the I to make the search case insensitive. Now you can see HTTP, HTTP, but again, this didn't update the file. So to update the file, all we need to do is put a tac I in the front. And now when we less the file and we search for HTTP, you see this has now been changed to HTTP, 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 right? It's all been updated. This is a really cool way you can find and replace things inside of files. You can update them that way. You can actually also use this syntax inside of Vim. So if I went to Vim, and I actually want to open the file. Let's say I wanted to change, what do we want to change here? Scroll through here. So let's say we want to take this phrase right here, this color, we want to change it to something else, right? So if I did /2E91FC, every match of that color here. There's only two matches. But if I want to replace every occurrence of it, I can hit Shift semicolon. So in other words, show a colon. And then I type %S. And then I type the thing I want to match on, 2E91FC. And I replace it with what I want it to be. 1, 2, 3. Just make it black. Do a global to search for every occurrence of it. Press enter and you can see it updated everything accordingly. Of course, we can do WQ, shift bang, less index.php, and then we can search for what we updated, and you can see it's there. Very, very cool. So that's it for that. We're actually now going to move into a different part of the course where we start to get a little bit more advanced. So in the next lecture, we're going to talk about determining the file types, the different files that you download. Then we're going to move into environment variables, and then we're going to get into how you can install things. We're going to deal with services and processes and getting help without Google. I mean, there's a lot in store for you. I just want to give you guys everything you need to become proficient in Linux. And hopefully I'm doing that. Leave me a comment, leave me a rating, so you can help me to understand if I'm on task or not in my goals here. Right, so guys, I will see you in the next lecture where we are going to dig in to file type determination. Bye. So in the last lecture, we had fun with the sed tool, and now we're going to dig into file types. So Linux has this really cool tool called file that will help you determine the file type of a file, right? So if I just go in here, you can see we've got some files here that I downloaded. And the extensions tell you the type of file it is, at least in Windows. But in Linux, that's not the case always, right? So let's say I ran file against this file here. You can see that it's showing that it's a zip archive, right? But if I renamed it to, let's say, a text file like this. And then I ran file against it. File still knows that it's a zip archive, right? And that's because file actually looks at the bytes. Let me quit this for a second. Let's go to head the first maybe 10 lines. PK is a magic byte sequence. These first 2 bytes right here. So this is hexadecimal, but these values correspond to binary, right? 5 is just 0, 1, 0, 1, right? That's 5. And then 0 is 0, 0, 0, 0. So these bytes in hexadecimal represent, especially these first few bytes, these are called magic bytes. This represents what kind of file we're dealing with here. And this is how Linux is able to determine if it is indeed a zip or a text. This is how Linux is able to figure out what kind of file we're working with. And I just used XXD to determine that. But you don't really need to know the details of that, because all you need to know is how to use file. Let's go back here. So I can say file, and I can see that this is a certificate file, right? And if I try to view it, you can see it looks like garbage, right? But the magic bytes tell us that it is a certificate file. Right? So I can do this, and these magic bytes tell us that this is a certificate file, right? This is how file works. And I said file a lot. And we can keep doing this. We can run file on this file sample right here, this document. You can see that file is able to determine that this is indeed a composite document. And I think we have, do we have a docx? No, we only have the old ones. But we can do this on anything, right? So I can say file. And you get the idea, right? Example, PNG. This is indeed a PNG image, right? So again, even if I try to rename that, file example PNG to, let's name it to a JPG. JPEG like that, right? So now it's a JPEG, or at least you might have thought it was a JPEG had you not gone through this lecture, but we can run file against it. And see that it is still a PNG. So I think that's pretty cool. Let's do one more. JSON data, right? And we can, of course, cap that out. And see that it is indeed JSON data. So that's how file works. It's really straightforward, really simple. In the next lecture, we are going to explore environment variables. So I will see you then. All right, see you in a bit. So in the last lecture, we looked at file and how you can use that tool to determine the file type. Now let's get into environment variables. So if we type env, you can see a list of all of the environment variables. So what is all this stuff, right? Well, it's really just, these are just values, right? Dynamic named values that are stored in the operating system, and different applications use these values to do different things, right? You can use it to customize how the operating system works. You can use it to customize how applications work. They can store information about like your default browser or an executable, or the path to an executable, your keyboard layout settings, things like that. And using env, you can see a list of all the environment variables in this session, okay? So let's say we want to look at one of them. We can say echo. Let's go up and find one that looks interesting. User. So we could just type env to see all of them. And by the way, in Windows, you can type set, S-E-T, to see all the environment variables. But in Linux, it's env. And if we wanted to find the user, we could type env to see all the environment variables. Or we could just look at the user one. And the way we do that, we would type echo and then $user. Bam. What about the shell? we can do that too. Scroll up. We see the shell here. But if we didn't want to type env and we just wanted the shell, we could type shell. And it tells us the shell we're using, which is ZSH. Echo path shows us the path. So if I type something like Vonnie, it's red because this command does not exist anywhere in our path. It doesn't exist in this sbin folder. It doesn't exist in this bin folder, or this sbin folder, or this bin folder, or this sbin folder. It doesn't exist in any of these folders. There's no path for that binary, right? So if I type which Vonnie not found. If I type which ls, I did not expect it to do that. Let's try something else. Which ping, there we go. I was expecting a path. I don't know why it didn't show the path to ls. But for ping, it shows us the path here. And user bin, this folder directory is in this path right here. That's why I can just type ping and it's not red, right? So this actually brings up a good point. So if I want to sort of expose an environment variable to any child process spawned from our current terminal, I can do that. So let's say, I know Google is 8.8.8.8. So I can ping it, no problem there. Well, I can export it as a variable called target 8.8.8.8, right? And now if I echo that variable I just created, you can see it says 8.8.8.8. So I can just do ping minus C1, meaning only ping it one time, or I can ping it 4 times. And instead of typing 8.8.8.8, I can type target. And it works, right? Now, if I close the terminal and I reopen it, it's going to go away. But if I open a new terminal from here, now I have a new process. And I try to use that, you can see it still works, right? It remembered this environment variable, even though I'm in a new process. By typing bash again, I'm just spawning a new child process of this current shell. But if I close it out, and then open it again, it fails, right? Because that environment variable is no longer listed in here. Let me show you. If I do export, do this again, and then I do env, you can now see the target is there, right? So I hope that is useful, and I hope that helps you to understand environment variables a little bit better. In the next lecture, we are going to get into installing stuff using apt, right? So it's going to be really, really fun. We've already done a little bit with this, but now we're going to get a little bit deeper. So I will see you in the next lecture. Bye. Alright, so last time we got together we talked about environment variables, and now we're going to dig into installing things in Linux. So it's a little bit different. In Windows, you can just download an executable and install it. Linux is a little bit different than that. Of course, you can still do it that way, assuming that the application has a Linux binary, like a .deb file or something similar, but usually you'll use a package manager. And apt is the go-to package manager for Debian and Ubuntu. So what you can do is you can run apt update tech-y. You run sudo in front of it. And what this does is it basically says, hey, pull down a table of contents, a file that contains all the new changes or additions to the software that I have installed on this computer. And this tech-y at the end just says, answer yes by default. It's going to say, are you sure you want to do this? And we're just saying, yes, we are. Right, so we put our password in. It's reaching out to these repositories and it's trying to pull down the latest. I call it table of contents because that's what it is. It contains the contents of new software available for download and installation. All right, so let's say you wanted to update your system. You could just run sudo apt upgrade, and that will just update the operating system. It'll install it, the latest version of the operating system. But if you had a specific piece of software that you wanted to search, or you wanted to maybe get more information about, you could run sudo apt search and then the name of the software. So let's type in Silent Trinity. And you can see here that this is an asynchronous collaborative post-exploitation agent. Post-exploitation meaning after the box has been exploited, this tool will allow a threat actor or a red teamer, penetration tester, the ability to move laterally throughout the victim environment. And you can see more information about this by running sudo apt show and then the name. And I tab completed, press enter. And now if I scroll up, get a lot of good information about this, right? So I see the package name, I see the version, I see who maintains it, how big it is. These are all the dependencies it has, and all these dependencies will be installed. You also have the GitHub page that this originally came from. And then you have a nice little description here. So this is what we saw earlier when we did the apt search silent trinity, but this gives us even more details about what this tool can actually do. So this is a nice little, I guess you could say, help system built into Linux that will help you get more information about packages you want to install. Now, if you have something you want to remove, we can do that too. So let's install this first. All we need to do is go here, type install, Control E to go to the end, tack Y, and let's install it. Now if I tap complete, you might need to try to find it by updating the DB and then doing locate silent. Let's see if we can find it. You can see here it's in this Python 3 directory, right? Or user bin silent trinity. So it's in our path. We should just be able to type this command here and run it. Control Shift C, Control Shift V, and here it tells us what we need to do. If you want to remove it, you can simply run the sudo apt remove. Now if you run this, it doesn't actually completely remove it. It still leaves behind the configuration files. And so, if you want to wipe everything and you want to completely remove the software, you need to add the tac purge option as well. And then we say yes, and that will delete it. So that's it. That's all I really wanted to show you, just how you can do apt update and apt upgrade. Apt update just pulls down the table of contents. Apt upgrade will install the latest updates to the operating system. And then apt search will allow you to search for a particular package. And then apt show will show you information about the package. You can also do apt info as well and get the same sort of results there. And then of course apt remove dash purge will completely get rid of the package. Alright, so in the next lecture we're going to dig into dealing with different services and processes. So I will see you in that lecture. Okay, so the last lecture talked about installing software using the apt package manager, and now we're going to dig into manipulating the services and the processes. So we can actually take a look at this. If you run systemctl, you can get a bunch of information, right? So I just press tab twice to see what you can do with this tool. And this is basically the way that you can manage the different services running on the operating system. So in Windows, you have the task manager, and you can see all the processes that are running. And you actually have the service control panel where you can look at all the services that are running. And here you can do the same thing. So if I type sudo systemctl status, let's look at the status for SSH. You can see immediately that it's loaded, but it is inactive, disabled, dead, right? So if we wanted to change that, we can just press the up arrow key and change it from status to start. But before we do that, Control U, let's prove to you that SSH is not running. See, this process is not running. The port isn't open for 22, which is the default port for SSH or SSH. But if we go back here, we can type start. Now, when we look at the status, you'll see it actually is running. And when we look at the port being opened on the system, you can see SSH is in fact running with process ID 4386. And of course, we could also grep for port 22 and we see it as well. So that's pretty cool. Now, if you wanted it to start at boot, you need to actually include the enable option, because by default, when you reboot the box, it's not going to restart the service. It's running now, but it's still disabled, right? It's not set to load at boot. So what we can do, you need to, of course, run sudo, and you can change this from status to enable. And now you can see it's set to enabled, which means it will start automatically at boot. So that's really useful. And talking about the processes, the way you would view your processes in Linux is you would look at the process tree. So PS shows you all the processes, but that's not the way it's typically used. Typically, people will type it PS AUX, because this will show you all the processes, including the command line arguments. So if we grep this, pipe it to grep and look for that process ID, we'll now find SSH. All I did was take 4386 from here, which we know maps to SSHD, which we started here. See, so everything is connected. And if you want to stop the process, you could just type sudo kill. And I like to do -9, and then I put in the process ID. And now if we try to grep for it, you can see it's not there. This is not the same as this. This column right here shows the process ID, and this is a parameter passed to this application. So grep has this parameter called tac-tac-color equals auto being passed as an argument to grep. And the second argument is 4386, which happened to coincide with the process ID of SSH. That's why it's showing up here. So the SSH binary is actually stopped. We can prove that by looking at the status. You can say it's still active, but when you grep for the port, it shouldn't show up in that same process. It looks like it respawned itself in a new process ID. So we killed the process, but it came back. And sometimes that happens because there could be a watchdog process that's watching for the process to die, and it just, resurrects it once it detects that it died. So that's kind of cool. One other thing you can do is that you can look at all of the currently running services, right? So if I do sudo systemctl list unit files, you can see I can see the state of all the different services running right now. So you can see I've got this service running, a few others. I'm pressing page down. So you can go through here and you might see something running that shouldn't be. You can see my web server service is not running. Networking service is enabled, which is good. It's good that it's enabled. That way I can do networking. But this is a good way just to check to see, if something should be running and it's not. You can look to see if the service is running. You can look in here, queue to quit. And one other really nice thing is if you type PS AUX with forest, it'll actually break down the parent-child relationship of your processes. So you see how in the right column, it's trying to show you, okay, lightdm spawned xorg, and this spawned nothing. But then underneath that, you have lightdm again, and that spawned this xfce4 session, which then spawned the SSH agent. And you can just track the entire process hierarchy, process tree. Without that forest option, it just looks like this, right? So the forest option is a really cool trick that a lot of people don't know about. It's a great way to get a little bit more value and utility out of PS. All right, so that's it in this lecture. Next one, we are going to dig into getting help without Google. So I will see you in that lecture. So the last lecture we talked about processes and services, and now we're going to get into getting help without Google. So, let's say you have this command you want to run nmap. So one of the easiest ways to get help on a command in Linux is just to type the command. Often that will show you the results of how to use the command. Now, this isn't always the case, but it is often the case. Alternatively, if this doesn't work, you can often type TAC-H, TAC-help, or just TAC-help to get more information. So if I type TAC-H, you see I get the same result. TAC-help, same result, right? And then, of course, you could look at the man page. The man page is the manual, right? The RTFM. If you type man in map, it gives you the full enchilada, right? This is everything. It tells you, basically what it is, and then it tells you a description, and then it gives you some examples on how you can actually use it. Now, if you don't want to go this deep, you just want to kind of get an overview of how something works, you can type what is, and then the command. And it'll give you sort of a brief overview. Network exploration tool and security port scanner. What is PowerShell Empire? Nothing appropriate. Now, if it doesn't have what it needs, it won't find it. But this is still a good tool that you can use to get basic information about different commands. So you can already see some of them that we typed. Find files by name. So, these are really useful. It's really cool. That's really all I wanted to tell you in this lecture. One of the quickest ways to get help on a command is just to type the command without any options. Or you could add the TAC-H or TAC-help. And finally, you can run man and the command you want to get information about. Or you can just use what is and the command name. So it's pretty straightforward, and it'll become easier as you become more conversant with Linux. As you use it more, these things will come to you more naturally. So in the next lecture, we're just going to talk about finding files on the disk using locate and find. All right, let's jump into that. So last lecture we dug into getting help without Google, and now we're going to use the find command, and also the locate command. So one of the great ways to find things on a Linux computer is to use locate, this command right here. Because the way this works is, first we need to re-index the locate.db file, and then by using locate, we can then search that local DB for files rather than the slower process of scanning the entire hard drive. So when you run sudo update db, it reindexes the local.db, and then locate immediately pulls it from that internal database. So that's really handy. And locate's really easy to use. That's why I showed that one first. Find is a little more difficult, but you can use find, of course, to find stuff on your computer. Now, by typing sudo find /, I'm telling the computer or the shell to find everything in the root all the way down. So I'm just searching the entire disk for everything. Right, so this is obviously the broadest search possible, but we can sort of clean it up by typing ini to search for a case-insensitive search for the file we just found earlier, and it should pop. You notice it was a lot slower, right? So let's see if we can do something here. Can I pipe this to time? Yeah. So you see, if I use time, this is another application. You can see it finished in about 0.15 seconds. If I do it with find, it took almost 0.6 seconds. So it's clearly a lot faster with locate. But the trade-off, of course, is that with find, you can do additional things. So let's see, I can type sudo find, searching here, and I can just look for all the exes, right? Glob it. Or what I can do after that is I can say, okay, give me all the exes, and then I want to run a SHA-256 sum. So I want to take a hash of all the exes. Let's see, so this didn't work. So what we can do now is I can just type man find exec, and I can see the correct syntax. I'm pressing in, and you can see here it's saying exec command, and a plus. So this is the way it should look. So I'm going to press Control-Shift-C, Q to quit this, go back up here, exec command. So this should do the trick. And it did. Now you see what it did. That's a good example of using man to figure out how to use a command. And also, you can see it actually did exactly what I wanted. It found all the exes on the system, and then it did a SHA-SUM. It finds and executes. So for each item found, it ran a SHA-256 checksum against it. It could have been anything, right? I could say, in this, Control-C. Don't run the checksum. Just run file against it. And you can see, of course, these are all PE executables, as we would expect. So that is really, really useful. And you can also look for other things. Like you can look for different extensions. I can say type is a file. And I can escape these parentheses. And then inside here, I can say the name is star.c, or the name is star.cpp. So we're just trying to look for C files, C programming files. Let's put these in quotes. And we didn't get anything. But we change this to something else. I believe I need a tech O here. There we go. So if you need to know what the tech O does, back to find / tech O in, and you keep going through it, and eventually you'll see these are the logical and or operators. And or. See, sounds pretty cool. Q to quit. So that's how that works. That's pretty straightforward. And find is a little bit more cumbersome than locate, but it's obviously a lot more powerful. So the next 3 lectures, we're actually going to dig into tmux. I'm going to show you how to truly level up your terminal by using tmux. It's absolutely amazing. And that will pretty much wrap up this entire course. All right, so I'll see you in the next few lectures. All right, bye. So in the last lecture, we talked about the amazing find and locate utilities. Now we're going to get into tmux. Now, I really like tmux, terminal multiplexer. This is a great way that you can manage multiple sort of terminal sessions inside a single window. And it's really a lot of fun to use. So the first thing we need to do is we need to create a file called tmux.conf. Okay, so if we type sudo vim tmux.conf, just like this, it's saying create this file in our home directory, and it has the name dot, meaning it will be hidden, and tmux.conf is the name. I'm going to press I to get in here, and we're just going to do a couple things. First, we're going to set the prefix. And so we're changing it from Control B to Control A. Control A will allow us to do a lot of the tmux tricks that you're about to see coming up. And we're removing Control B. That's what that basically does right there. Then we're going to set the history limit to 100,000 so we can go back through our command history. And then we're going to use this plugin called tmux plugins. We're going to get that in a moment. And then we're going to add some special color effects. We're changing the background color and the foreground color. Looks like I messed that up. Nice. Okay, and then we're going to set the bind keys. And pay attention to the syntax as you type. The colors, because the colors will change. If you typo something, it won't look right. All right, and we're going to make it behave like Vim, so we can press GG to go up and capital G to go down, things like that. And finally, we're going to tell it to run our tmux plugin. Okay, that looks right. Shift ZZ, tmux new tech S test. It starts a new session. I'm going to type hush login to hide the message that prompts by default when you start a new session. And now you can see we've got this bar at the bottom, and it has the name of our session, and we have the command prompt here. All right, now this is pretty cool. So the first thing we need to do is press Control-A-I to basically invoke or engage the configuration file. Then we need to get the tmux logging stuff. Okay, so if we go to cd opt, you'll probably see that it is not here. So let's go ahead and grab it. Sudo less tmux.conf. And what do we need? Yeah, we need this tmux logging plugin. Control-Shift-C. Let's go to our browser. And all the good stuff is usually on GitHub. So what we need to do is we need to clone this repository. Okay, so we just click code, click this little clone button here, minimize this, quit. I press Q to quit, clear. Then I can type sudo Control-Shift-V. And we want to clone into this folder here. Notice that folder matches this opt tmux-logging matches opt tmux-logging. Okay, that's really important. It has to match. Then we can type tmux source file. Now if we press Control-A, Shift-P, you can see it says logging. This means everything we type now is logged to this file. So if you're typing along and you want a transcript of all the commands that you typed, it'll now be saved. You can retrieve it from that directory, which I think is really, really cool. So that's how you set up tmux. In the next lecture, I'm actually going to show you how to use it. So we're going to get into that in the next lecture. All right, bye. And so in the last lecture, we went ahead and set up tmux. And now I'm going to show you some practical use cases for it. Let's exit. Clear. The way you start a tmux session, you type tmux new, you type a name, like Linux Basics. You can see it shows part of it down here. I press Control-A, comma, I can rename this window, right? And then if I press Control-A-C, I can add a new window, and then Control-A, comma, I can do that as well. I can rename this one. Right, so now we have two. Control-A0 takes me back to this window. Control-A1 takes me back to the other one. So you see this is window 2. Control-A1, Control-A1, or sorry, Control-A0, echo window 1. So Control-A1, Control-A0. The nice thing about this is if I close out of this window, close the whole thing down, what happened? Everything's gone, right? Well, you could type tmux ls to list the sessions, and you see I've got the session still running. So all I need to do is type tmux attach session, and it came back. So normally you couldn't do this, right? If you were SSH into a computer and you close the terminal, well, now you're no longer connected. But with tmux, you can stay connected. It's kind of like Terminator, it's kind of like Screen, but I prefer tmux just because, it's the new hotness. And, I like the hotness. So that's one of the reasons I use it. I think that's pretty useful. Now we can split the pane. If I press Control-A, Shift grapes, I now have the pane cut in half, right, vertically. And Shift grapes, by that I mean Shift 5, the percent sign. If I do Control-A, Shift double quote, it splits it horizontally. And then I can press Control-A left to move back to the left pane, and press Control-A, Shift double quote to split it in all these different ways. So I can have all these different things running, right, at the same time. All these things running at the same time, and have a nice little overview of everything that's going on. If I press Control A and hold down Control and keep pressing the left arrow, I can move to the left. Control A, hold down Control, keep pressing the right arrow, I can move to the right. Of course, you can do the same thing with up and down. So that's kind of cool. And those are really the big things you really need to know about this. If you want to exit a pane, of course, you could just type exit, or you can press Control A, X, and then press Y. It'll kill the pane that way. And that's pretty much how I use it. Now, I typically use it when I'm engaging in, when I'm playing CTFs. So Hack the Box is a CTF I play. It helps you, when it comes to penetration testing, ethical hacking, and all that stuff. Basically provides you a virtual environment or a lab to learn. And here's Hack the Box here. I'm logged into it. You basically can download the VPN connection pack. And so, in one of these tabs, I would name it, if I go to Control A 0, clear, I would name this Control A, comma, VPN, right? And I have my VPN connection here. And then Control A1, I would name this something like reconnaissance or recon. And then this is when I would do like my pinging of the targets and, preparing my attack for the penetration test. But that's pretty much how this works. I hope you find TeamUps useful. I use it all the time. I think it's an excellent tool that I wish more and more Linux administrators and network engineers and cybersecurity professionals would actually start to use. And, I hope you found these lectures useful, and that will be it. So I will see you guys around. Keep in touch. Leave a comment. Reach out to me on email. Leave a comment. I definitely want to keep in touch. I definitely want to help you guys continue to build your Linux skills. But really, the best way to learn Linux is just to continue to use Linux. Continue to use it. Don't be afraid of it, and try to teach it to others. Because when you understand something well enough to communicate it to someone else, it really cements, your own knowledge of the thing that you're communicating. Right. So don't be afraid to do that. Don't be afraid to record videos like I'm doing. Part of the reason I did this is just so that I can strengthen my own understanding of Linux, right? So there's no shame in doing that at all. Nobody has all the answers. All right, guys, so that's it. And I hope you have a great time, great day.